All right, Ms. Slyman here to look at some examples of simplifying exponential expressions. And so first rule, multiplying powers, that means I'm going to add the exponents. So x squared. Dividing, I'm going to subtract the exponents. 4 minus 10, negative 6. But it says to write with positive exponents, so I'm going to use that rule that says this is really 1 over m to the 6th. An alternative way to think about this is to rewrite it as m to the 4th over m to the 10th. And then think about this is m times m times m times m over m times m times m times another 6 m's. When I cancel out m divided by m to make 1, that's going to leave me 6 m's in the denominator. It's one of our rules. It's one of the reasons why this rule is true. All right, negative 24 divided by 8, that's negative 3. Please don't subtract 24 and 8. People do that a lot. Not true. This is negative 24 divided by 8. X to the 4th divided by x squared, y to the 3rd divided by y to the 5th, y to the negative 2, or there's 2 more y's on the bottom than there are on top, y squared. All right, negative 3 out here. So that means I'm really going to have 1 over 2x cubed, y squared, all cubed. 2 cubed is 8. X cubed cubed is x to the 9th. Y squared cubed, y to the 6th. Negative 3x squared, y to the 4th to the negative 2. 1 over negative 3x squared, y to the 4th squared. Notice this negative is a negative number. It's not an exponent. So it still is negative down here when I move it to the denominator. But now negative 3 squared is positive 9. X squared squared, y to the 4th squared, y to the 8th. All right, negative 3. In this case, 2 to the negative 3, y to the negative 6, over z to the negative 12. I'm separating it this way to help us see that this is going to come on top. Z to the 12th, 2 to the negative 3, that's going to be 1 over 8. Y to the negative 6 comes down to be positive 6. So there's our examples of simplifying expressions. As always, if you have questions, please ask me about them.